an electric field as well as a magnetic field. Initially they're not moving, but I'm going to turn on the electric field here, and I'm actually going to put some tree pollen, which you can hopefully see. Whoa, that's a bit much, but you get the picture. You see that they're rotating in a clockwise sense. So the question is now, what is happening here? Is it the positive ions that are causing this motion and carrying along the pollen? Or is it the negative ions, right? If I turn off the electric field, then there is no electric field, nothing is moving. This will come slowly to rest. As I turn on the electric field, the ions here will be accelerated in the electric field. As they start moving in the electric field, they feel the effect of the magnetic force, and that is what makes them rotate. So you have to see whether it's the positive or the negative ions or both that carry the pollen along in a clockwise direction. So take a minute to think about it and then enter your votes using the PRS system. And no talking yet. Come up with your own answer. Okay, I still need 10 to 20. I still need about 10 to 20 votes here. So please enter your answers. We have a disagreement clearly here. About a 50-50 split between two answers. I'll let you guess which ones. So turn to your neighbor and see if you can, and remember, finding one correct answer, for instance, the negative ions, doesn't mean that the positive is necessarily true. So you have to really try out both. Go ahead, check with your neighbor and see if you can agree.
How do you know how to weigh the electrostatic and magnetic forces? Like, how do you know which one is greater?
Well, you don't really
Okay, so
need
please
to
enter
know
your
which one's
answers.
greater because one is pointing in the x direction, the other one is pointing in the y direction. So you have to superimpose them to get the direction of the force, right?
Half a minute left. See if you can come to some agreement. There's about 20 seconds left, so enter your answers. Okay, well, let's see. Okay, so we started with about a 50-50 distribution on choices 1 and 2. And right now, we're at 1/3 for 1, 1/3 for 2, and 1/3 for 3. Clearly, we need to do some more thinking and talking about that. So I've started by making a drawing here a top view of the bottom of what we see on the screen here. So that's the inner cylinder. This is the outer cylinder. Which way does the electric field point between those two cylinders? From plus to minus, so that means upwards at the bottom and, slightly inwards on the sides, but we're going to concentrate on this area right here. So what about the magnetic field? Which way is it pointing here? The magnetic field at the North Pole is pointing toward you, so the fields come out of the magnet and then curl back in. So right here, they point into the board.